Hello everyone, Mr. Schultz here. Welcome to Integrated Math 1, and we're going to be talking about 9.2, using data. So make sure you put your first and last name up here at the top, and make sure that you put your period number as well. So the first part we're going to do is part 1 of 2 of vocabulary, where will be the term, definition, and examples. So population is all the members of a group of interests about which data will be collected. So if we wanted to collect data about all the students, so all the students at Savannah, that would work. Or if we just want to collect data on all the freshmen, or all freshmen at Savannah. And so we would look up we would try to figure out how we're going to collect that data. So let's go on to the next part. So a sample is a subset of a population. So how are we going to collect the data on all the freshmen? Or how are we going to collect data on all the students at Savannah? Well, we wouldn't just go to a football game because not all people would go to a football game. We'd have to make sure that it's random. So we're not being biased right here. So random, and it represents the population. So if 40% of the population of the group we're looking at is female, then we'd want the population, if we randomly pick it, then the sample population should be around 40%. If we go too heavily away from that, or either in the positive going into like 90% to like the negative, either 10%, well then that's not going to be a true representation of the population. The next thing we have is bias. So with bias, it's going to be an error that results in a misrepresentation of a population. So that could be several different things. We get bias from interviewing only people who go to basketball games. Well, this would be a bias in our sample set that we just were trying to get. It wouldn't give us an accurate reading of the true Savannah population, or like if we wanted to be specific, the freshman population, because not all freshmen go to the basketball game. All right, well, let's go into example 1, music. Dayani wants to know what favorite type of music is among young adults. To find out, she asks all the young adults she sees leaving a country music concert. Identify the intended population and determine the population sample bias. Okay, well, on this, she's looking for the intended population, so let's make the intended population is young adults. The potential sample bias is the fact she is asking outside a country music concert. It would lean heavily in the preference of, let me spell that right, preference of country music. So yeah, like you go to a rock concert, most of the people at a rock concert are going to be like rock and roll. You go to a hip hop concert, people are going to be like, I like hip hop. You go to a country music concert, they're going to be like, I like country. That's what would happen most of the time. You probably don't want to go to those type of events and ask that question because the sample bias is they like what they're going to see. You probably want to ask probably every third person going into the classroom or something like that, or going into school. Ask every third person. That gives you a random um, sample. All right, let's go on. Example 2. Now there can be potential biases in the question. So, for example, an online newspaper asks, do you support opening the new environmentally friendly factory in the city? Okay, well, it looks like the potential bias in the question, um, the potential bias in the question could be the environmentally friendly, could be the phrase environmentally friendly. Identify whose interests may be served by the question. Okay, well, you know, this phrase puts the factory in a positive light. The factory owners or people whose interests would benefit from a factory being built would enjoy this, enjoy having a positive spin, positive spin on the question. So there are many ways you make something positive, and there's many ways you can make things negative in a question, and that gives a bias in the question. So let's go on to this 3. An online survey asks, do you support building a new football stadium which will be funded by increased taxes? Well, the potential bias in this question revolves around the phrase increased taxes. Whose interest might be served? I mean, the people who don't want this built, this would serve them because, people who don't want this stadium built would be served by this question. Why? Okay, well, let's go into that. Nobody likes paying more taxes. Just having this question, just having the phrase increased taxes would cause some people to not support this at all. There we go. All right, let's go on to vocabulary part 2 of 2 in 3, 2, 1. So, a statistic is a measure that describes a characteristic of a sample. So this could be, we're talking about mode. This could be when we have median. This could be mean. And these are the centers. Now, what we could also do, we have these outliers. Now, these are all statistics. Like, it's all like, it's just like, it's just describing the characteristics. We can describe the shape as well, but like for right now, we're going to talk about mean, median, and mode. Pretty much. Oh, don't forget the part 2 of 2 right here. pretty much we're going to be talking about like, hey, what's the middle of the data? Like, which can we use to properly describe this data? All right, let's go on to the next examples. All right, so we have example 3, data summaries. Teaching. A teacher wants to tell students how the average student did on the exam. So he looks at the scores in his gradebook. 2 students scored a 0 because they stopped showing up for class in the last month and did not take the exam. He uses the mean 71 as the measure of data. Does the mean accurately represent this data? So the mean is 71. He added up all of them and then he divided by the total number. Well, not necessarily, because, like, no. The 2 zeros do not reflect how everyone else did. Like, the lowest score somebody got was an 82 if they took the test. Since they took the test, they got the lowest score was an 82. Now, it's just that the zeros caused the whole score to be dropped down. These outliers in the data skew the data. So if we have really, really low numbers, it's going to skew our data down. Well, let's see what happens. Now, a more accurate would be using the median. So let's cross these out. So I can cross them out and go 1, 1, 1, 1, 1, 1, 1, 1. So it looks like the median is 87. And it looks like the mode, well, there's 391s. So each of these has a better representation of the data. For example, 87, I mean, it's not skewed as much. Like if we took off the zeros, like our score would have been 88. I do believe that. I look at this, I'm like, all right, let's take off 2 of the data. Well, that means, yeah, it would go up to like 88. And that's really close to this median of 87. So this outlier doesn't really affect the median as much. It only affects the mean. Now, this mode is nice because it tells us, hey, look, most of the students scored this, 91. Now, if it's 3, it's not as much as, if we had like 8 out of 30 students test and got that. But looking at this, it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 out of 9, 1/3 of the population scored a 99 and 91, and that's really good. All right, let's go on. So before we go, no, the mean does not accurately represent the data because I already stated it. It was pretty much the lowest score right here was 82, and the median number in the mode really showed off like what the scores represent. All right, let's go on to example 4, the last one. So example 4. So a group compares 2 soccer players who play the same position for different teams. They make a graph of the number of goals scored throughout the season for each player. Do the graphs misrepresent the data? Whose interest might be served by the representation? Okay, looking at this, I'm going to tell you right now, they're pretty much the same numbers. But we can have how we represent the data change so that it looks like one is different from the other one. So what is the purpose of the graph? The purpose of the graph is to show how the goals scored as the season progresses. And we see, okay, look, it looks like this guy's scoring at a lower slope. He's not scoring as much, it looks like. And we look at player 1, and it's like, oh, look, the slope of him scoring is like increasing compared to how many months it's been. So like, look, this guy's scoring really, really high. But like, if you actually looked at it, look, that's 30, and look, that's 30. So our scale has been skewed so it doesn't look like. We've smashed down the scale so it looks like player 2 isn't doing as well. So what are the differences? Just said it. The y-axis, the scale of the y-axis has been changed. It actually looks like a half, like player 2 appears, half as much because it's growing by tens instead of fives. So the graph part of it. Now this is the talk about the rub right now. It looks like his graph is half as tall because his y scale is twice as big, whereas player 1, the y scale is more reflective of what's there, so it looks like an accurate graph. So how does this affect the representation of the data? Okay, well, let's type it out. It appears that one player is playing at a higher caliber of play in comparison to the other player. Player 1 seems to be the better player. So who is best served by this misleading representation? Well, I mean, I can think of a few people who would want this. Player 1 wants, or his manager, or his agent. So he would like this comparison because it makes him look better. This comparison because it makes his player look better. All right, guys. Well, that's it for our examples. Good luck with your classwork, and I will see you guys when I see you. Have a good day. Bye, everybody.